Today, we're going to be talking about angle relationships. The first type of angle relationship are adjacent angles. Adjacent angles are angles that share a common vertex and a common side. On the left, you'll see an example of adjacent angles. Angle CBE and angle EBD are adjacent angles. They share the common vertex of B, and they share the common side of BE. To the right, we have a non-example. As you can see, we have angle ABE and angle CBD. They both share a common vertex, but they do not share a common side. Therefore, these two angles are not adjacent. Another way to think about it, the word adjacent means next to. These two angles are across from each other and not next to. The second type of relationship are vertical angles. A vertical angle are two non-adjacent angles opposite each other formed by two intersecting lines. Another key characteristic is that all vertical angles are congruent. That means they have the same measure in degrees. Below to the left, we have our first example of vertical angles. As you can see, we have two intersecting lines, and we are given four angles, A and B. Well, we know that all vertical angles are congruent. Therefore, we can say that angle A is congruent to angle A by utilizing our tick marks. The diagram also has another set of vertical angles, where angle B and angle B are also vertical angles because they're formed by two intersecting lines and are directly across from each other. We know that all vertical angles are congruent, so let's use our tick marks to identify that both angle B's have the same measure. In this case, I'm going to use the color blue and 3 tick marks to let all of my readers understand that both angle B's have the same exact measure in degrees. Below to the right, we have our first non-example. Remember, vertical angles are two non-adjacent angles opposite each other formed by two intersecting lines. In this particular case, we actually have more than two intersecting lines. We have line segment CE, line segment AB, and line segment DB. We do have 1, 2, 3, 4 angles, just like our example off to the left, but we have more than just two intersecting lines. Therefore, we have no vertical angles, and we can conclude that none of these angles are congruent. The third type of angle relationship are complementary angles. Complementary angles are angles that add to 90 degrees. Below on the left, you'll see two examples of complementary angles. The easiest to see is the second example off to the right. I have angle A and I have angle B. 65 plus 25 is 90 degrees. Therefore, angle A and angle B are complementary. The furthest example to the left is a little bit harder to see. But one of the key factors we need to understand is that this tick mark looks like a little box. That indicates that this big angle right here is 90 degrees. Therefore, we can conclude that angle 1 plus angle 2 is equal to 90 degrees. Therefore, angle 1 and angle 2 are complementary. Off to the right, we have our non-example. Now, this is very similar to the furthest one to the left. Angle 1 and angle 2 look complementary, but what is missing? We can never assume in math, because this big angle does not have the same tick mark as this example all the way to the left, we cannot assume that the angle is 90 degrees. Therefore, angle 1 and angle 2 are not complementary. Supplementary angles are our fourth relationship. Supplementary angles are angles that add to 180 degrees. Below are two examples of supplementary angles. Let's concentrate on the easiest. Angle P is 120 degrees. Angle Q is 60 degrees. We know that 120 plus 60 equals 180. Therefore, we can conclude that angle P and angle Q are supplementary. In the second case, we're looking at a straight line and then a ray forming angle 3 and angle 4. What we have to remember is that all straight lines have an angle measure of 180 degrees. Well, if angle 3 and angle 4 add up to 180 degrees, I can conclude that angle 3 plus angle 4 are supplementary. The fifth relation we're going to talk about are linear pairs. Linear pairs are a pair of adjacent angles that are on the same line. Our first example of linear pairs are down below on the left. As you can see by the diagram, you see angle 1 and angle 2 are on the same line. Also, angle 1 and angle 2 are adjacent, meaning next to. Therefore, we can say angle 1 and angle 2 are linear pairs. And since they're linear pairs, we know they're on the same line, and we have to remember that all lines have a measure of 180 degrees. And since angle 1 and angle 2 are linear pairs, we can also conclude that linear pairs are also supplementary. Below to the right, we have a non-example. As you can see, angle BDA and angle ADC are angles that are next to or adjacent, but they are not lying on the same line. Therefore, this is a prime example of non-linear pairs. The last relationship we're going to talk about is perpendicular lines. Perpendicular lines are lines that intersect at a 90-degree angle. Below to the left, we have our first example of perpendicular lines. Below, you can see that we have line CB and line AD. The question is, how do we know that they intersect at a 90-degree angle? Well, as you can see, we have our 90-degree angle tick mark. The tick mark indicates that this angle right there is 90 degrees. Well, now we can see that line CB and line AB intersect at a 90-degree angle, making them perpendicular. And the proper way to write this would be line AD is perpendicular to line CB. Where, as you can see, this upside down T is the notation for perpendicular. Another point of emphasis is to recognize that since this angle is 90 degrees and this is line AD, AD is a line, meaning it has a measure of 180 degrees. Well, we can now conclude that this angle right here is also 90 degrees, which makes this angle 90 and this angle 90. Two perpendicular lines will have four 90-degree angles. Off to the right, we have our first non-example of perpendicular lines. As you can see, we do have two lines, lines AD and line CE, that intersect. But the question is, do these lines intersect at a 90-degree angle? Remember, in math, we can never assume. All four of these angles do look like they are 90 degrees. But since there is no tick mark indicating that this, nor this, nor this, and nor this are 90 degrees, we cannot assume that these two lines are perpendicular. Therefore, we can conclude that this is a prime example of non-perpendicular lines. Lastly, we will speak about assumptions and learn about the sum of the interior angles of a triangle. As you can see, off to our right, we have our example of a triangle CON. Let's properly name this triangle with the notation triangle CON. We could also name this as triangle ONC or triangle NCO. There are multiple ways we can name this triangle, but all we need to know is that we name triangles by all three vertices. The first question we got to ask is, can we assume angle O is a right angle? Well, remember, a right angle is an angle that measures 90 degrees. Well, it looks like angle CON, which is angle O. It looks like 90 degrees, but remember, it does not have the proper tick mark, the square-shaped tick mark, indicating that angle O is 90, so we cannot assume angle O is a right angle. The second question we got to answer is, can we assume that angle C and angle N are congruent? Well, the only time angles can be congruent is if they have the same measure, whether it be indicated by a degree measure or by tick marks. But neither angle C nor angle N have tick marks or given angle measures, so we cannot assume that they are congruent. The last question is there anything that we can assume? Well, we have the geometric figure of a triangle, a three-sided shape, and we have no tick marks, indicating whether the sides are congruent or the angles are congruent. So, is there anything that we can assume? The only thing that we can assume is that in all triangles, all three angles will always add up to 180 degrees. Now that we've completed all of our angle measurements and relationships, let's have some practice.